Imagine preparing for a flight, eager to take off and head to your next adventure, when suddenly you hear that the plane has been delayed due to weather conditions. While passengers often associate weather with delays and discomfort, the effect of climate on the aircraft itself goes far beyond the occasional thunderstorm or snowstorm. The truth is, climate has a direct and profound impact on aircraft performance, safety, and maintenance, influencing everything from the takeoff to the landing and even the longevity of the plane. The airplane you're about to board isn't just a marvel of engineering, it's also highly sensitive to changes in atmospheric conditions. From blistering heat to freezing cold, humidity, wind, and heavy precipitation, each climate variable plays a role in shaping the way an aircraft operates in the sky. And as the world's climate continues to change, it's becoming increasingly clear that understanding these effects is vital for ensuring both the safety and efficiency of air travel in the coming decades. One of the most critical ways that climate affects aircraft is through temperature. Aircraft are designed to perform optimally within specific temperature ranges, and deviations from these parameters can strain the aircraft's systems. During hot weather, air density decreases, meaning that the aircraft's engines must work harder to generate lift. This results in the need for longer runways during takeoff, as the reduced air density demands more power to achieve the necessary speed for liftoff. On especially hot days, airlines may have to reduce the number of passengers or the amount of fuel loaded onto the aircraft to ensure that the plane can safely take off in the warmer air. This can lead to delays, cancellations, or changes in flight plans as airlines balance safety concerns with the limitations of their planes. Additionally, the heat can put added strain on the aircraft's systems, including the engines and the air conditioning units, which work harder to keep the plane cool. On the flip side, extremely cold temperatures present their own set of challenges. Sub-zero temperatures can cause various issues for aircraft, especially when it comes to starting engines or ensuring proper functionality of critical components like hydraulics and electronics. For instance, in freezing weather, fuel and oil can thicken, which can impede the aircraft's ability to function efficiently. Pilots and ground crew have to perform additional pre-flight checks, such as de-icing the plane to ensure that the wings are free from ice buildup. Ice can dramatically alter the aerodynamics of the plane, reducing lift and making it harder to control, so it's essential that every inch of the plane is thoroughly cleared of ice before takeoff. This process can be time-consuming, adding to delays and increasing operational costs. The role of humidity in aviation is another factor that's often overlooked by the average traveler, but it plays an important part in how the aircraft functions. High humidity can create more opportunities for moisture to enter critical components of the aircraft, particularly the engines. This can lead to corrosion over time, decreasing the lifespan of the engine and other metallic components. Moreover, high humidity levels can cause fogging inside the cockpit or windows, reducing visibility and making it difficult for the flight crew to see. On the other hand, low humidity can lead to static buildup and issues with sensitive electrical equipment. Aircraft manufacturers account for these varying humidity levels when designing planes, but extreme fluctuations in atmospheric moisture, often due to shifting weather patterns, can still cause challenges for aircraft maintenance and reliability. Wind is another powerful force that shapes an aircraft's performance. While aircraft are designed to fly in various wind conditions, strong winds, especially crosswinds, can make takeoff and landing more difficult and dangerous. Crosswinds, which occur when wind blows at an angle to the runway, can push the aircraft off course during landing or takeoff, requiring pilots to use greater skill and precision to maintain control of the plane. When wind speeds exceed certain thresholds, pilots may be forced to delay takeoff or landing until conditions improve, resulting in longer waits for passengers. In some cases, airports may even close temporarily due to excessive wind, disrupting flight schedules and affecting the aircraft's ability to safely operate. On long-haul flights, strong tailwinds can benefit aircraft as they help push the plane along its route, reducing fuel consumption and travel time. However, the unpredictable nature of wind patterns, exacerbated by climate change, can make flight planning more difficult. Climate change is exacerbating many of these issues as more extreme weather events become more frequent and intense. For example, as the global climate warms, the incidence of heat waves is increasing, which means more days of extremely hot temperatures where aircraft performance could be compromised. At the same time, rising sea levels and increased flooding may threaten airports situated in low-lying coastal areas, making it harder for airlines to operate in certain regions. More frequent and intense storms, such as hurricanes and typhoons, are also increasing the potential for damage to aircraft. Airports may be forced to close or limit operations, and even if flights are able to take off, the safety risks increase during turbulent weather. For aircraft already facing the strain of extreme weather, the long-term impact on their performance is undeniable. Increased stress on engines, components, and systems can lead to more frequent repairs and maintenance, raising operating costs for airlines and potentially affecting the overall safety of the aircraft.